With surds, there are a few rules you need to know about. The first one we're going to look at is when you have, it's all to do with root surds. When you have a root of, let's say, A times by a root, let's say, B. Okay, what our rule says is that is equivalent to or equal to the root of A times B. Okay, so as an example, the root of 5 times by the square root of 3 is equal to the square root of 5 times by 3. That's a 3, which hopefully you can see is the square root of 15. Okay, another one. Times by the square root of 5 is equal to the square root of 12 times 5, which is the square root of 60. Now you might be thinking, how is this useful to me? What is this doing to help me? Okay, well, it's most useful in reverse. So for instance, if we had the square root of 75, okay, we know that two numbers times together to make this, we can split these up. So I know that 75 is 25 times 3, and I've picked 25 because I know 25 is a square number and I can find the square root of this, so I'm making this more simple. The square root of 25 is 5. Root 3, I can't simplify that anymore, so that stays as root 3. Now here I can write this as 5 root 3. Okay, so I've simplified this down. Square root of 75 is actually the same thing as 5 root 3. Let's have a look at another one. Okay, let's have a look at the square root of, let's say, 48. Okay, 48. I'm thinking of numbers that go into 48, hopefully one of which is a square number. Now I've got two options here. I'm going to say it's the square root of 4 times square root of 12. Apologies for that, 12. Hopefully you can see the square root of 4 is 2. Now 12, break this down again, it's the square root of 4 times by the square root of 3. So I end up with 2 times by square root of 4 is 2 times by the root of 3. If I simplify this down, 2 2s are 4 root 3. Okay, now I could have done this another way if I just put a line in here. Okay, 48 is actually also 3 lots of 16, so I could have done is equal to the root of 16 times by the root of 3. And I know the square root of 16 is 4 square root of 3, so I end up with the same thing, 4 root 3, 3, and 4 root 3. Same thing there as I've got there. Okay, so you need to be able to spot these, and it's all to do with finding square numbers here and here, alright, that times by something else to give you your original number. Right, the other rule that's going to be important to us is division. It's exactly the same for division. Alright, and I'll use C and D this time. What we're going to say is the square root of C over D, like that, is exactly the same as the root of C over the root of D. Now, again, this is useful, more useful really in reverse. Okay, for instance, if I had the square root of 24 all over the square root of 6, I could say that's equal to the square root of 24 over 6. Now I know that 24 divided by 6 is 4, so it's root 4. I know what the square root of 4 is. It's 2. Okay, let's have a look at another one. One more. If I have something along the lines of the square root of 15 over the square root of 5, my rule says that I can make this into one square root, the square root of 15 over 5. 15 over 5 is 3, so root 3. Now that's a lot more simple there than it is here. Okay, so this is useful for us to simplify things down, really. Okay, before you come to the lesson, I'd just like to try and simplify down a few of these, please. So the first one I'd like to have a go at is quite an easy one. Using our first rule, square root of 90. Could you make that more simple for me? I'll check these in class. Another one like this, the square root of 150. Okay, again, get it into the form that we had in the examples. And then some others. If we have a look at the square root of 54 over the square root of 6. Can you simplify that down for me? Okay, so I've got those three, and then we'll go through it in class.